Hey guys, I'm back, and today we're going to be talking about the graphs of circular functions. So, first thing we're going to talk about today is periodic functions. So, right now I'm going to demonstrate an example of a periodic function. Now we're going to discuss what a periodic function really is, definition-wise. A periodic function is a function that repeats its values at regular intervals. And you'll see that I'm writing that definition down right now, just so you can see it for visual purposes. Now, we already know from our previous lesson over unit circles that a complete rotation around the circle is going to be equal to 2 pi radians, which means that the circumference of the circle is going to be equal to 2 pi. Since we know that the circumference of our circle equals 2 pi, this tells us that in our equation, the least possible value of p for which sine and cosine repeat is going to be equivalent to 2 pi. So this is going to tell us that the sine and cosine functions are both periodic functions, and it's also going to tell us that p is going to stand for 2 pi, as we already know, and I'm just going to demonstrate how that shows itself in the sine and cosine functions. Alright, so down here I've taken the initiative to write down this chart, and basically this chart is going to tell us how the increases of s affect sine and cosine. So as you see here in the first column, you'll see that as 0 increases to pi over 2, sine is going to increase while cosine is going to decrease. And then you'll see as pi over 2 increases to pi, sine will decrease while cosine will also decrease. And it's just going to work that way for the rest of them. You'll see for this next one, sine decreases and cosine increases. And then for that last row, sine is just going to increase, and so will cosine, as 3 pi over 2 increases to 2 pi. Okay guys, so now we're going to be focusing on the function of sine, and here you can see that the graph of sine is continuous throughout the entire domain, and that the domain is going to be all real numbers, whilst the range is from -1 to +1. And now you can see me pointing to the x and y values, and if you were to input those x values, that would be what would come out. And there you can see this a little graph I drew on the side. And something that you'll notice about the sine function is that the line does go through the origin, and that's something that will help us a little later when we're trying to differentiate sine functions from cosine functions. So just take a good look at it. So another thing I wanted to add is how the graph reflects how the period works. And you'll see here that I'm demonstrating with my finger that the graph goes up then down, and then it begins a new cycle at 2 pi. Therefore, 2 pi is the period of the graph. Alright guys, so now we're focusing on the cosine function, and you'll see that the domain is also all real numbers, just like the sine function, which means that the graph is continuous over the entire domain, and you'll see that the range is from -1 to 1. And here you'll see some x values when implemented. These are the y values that will come out. For instance, if you input 0, you'll get 1 as the outcome. If you plug in pi over 2, you'll get 0. If you plug in pi over 4, you'll get square root of 2 over 2. And this is the range of periods for this graph. You'll see here that the graph restarts again at 2 pi, making that the period, and that starts a new cycle. And you'll also notice that here the graph does not cross at the origin, which is another thing that we can use to differentiate cosine from sine. And you'll see the same thing here, and that's going to happen with all these cosine functions for now. Okay guys, so the next thing we're going to talk about here is amplitude. Now, the main thing to remember about amplitude is that it's actually a pretty simple concept in the beginning, at least here in 4.1. And basically the amplitude is just going to tell us the height of the graph, how wide the graph is stretching, how wide the function is going to stretch when it's written on the graph. So you'll see that later on when I show you a few examples, or you could have seen that whenever you went back to the sine and cosine graphs. You could see that the amplitude wasn't very high. It was just around 2, I believe. Correct me if I'm wrong. So here, as you can see, I'm just elaborating even more on amplitude and showing you guys how it works in relation to the sine and cosine functions. And here, I'm just quickly showing you how to solve for a period within an equation. So you're about to observe what I do here. here I'm just quickly showing you how I work through this last function, and I'm going to solve for the period and the amplitude. And after that, that will be all for today. Thanks for watching.